Hello, friends and followers. So on my deathbed, am I going to regret fixing this radio? Days and days and hours spent working on it where I could have been having more fun, maybe helping people in need, doing something productive instead of fixing an old radio. Maybe I will feel guilty about this someday. Anyway, as they say in New England, this thing's been a wicked pissa. And that sometimes means something is very good, I think, or very bad. In this case, very bad. So this harmonic generator is a real pisser to fix. I don't think anything was wrong with it electrically, but mechanically and how it was constructed with parts close to each other and things bent around and touching. I probably fixed about 3 or 4 potential shorts in this thing. So used to be like this would come on and work randomly. I didn't know why. I didn't know if it was a voltage problem, and maybe it was. I spent time tonight fixing the voltages with regulators. I'll show those off later. But in any case, there's the wave on the oscilloscope. The harmonic wave of I guess what, 52 harmonics. And if I beat on this thing now with a screwdriver handle, I don't get any more fluctuations in the output. And believe me, this has been a very difficult journey to get this thing figured out. And it's finally working, so I can compress these boards. There's no change in my output. So finally, I think this thing is stable. So what did I find? Okay. This little transformer here is super delicate. Nothing was wrong with it. But as you're traipsing around through here trying to fix things, you don't want to break these little fine wires. They're super fine. You just don't want to break them. So a long time ago, probably a month ago or something, or weeks ago, I changed a few resistors in here. They're out of spec. So I was just going through changing all sorts of things, just looking for things that are out of spec. And that didn't really make much difference in the operation of this board, but maybe it did. Anyway, so here's what I found that was really, really screwing the pooch on this thing. These there's a little grounding strap in the middle, so that silver thing down there is ground. And these capacitors can get pushed down by previous owners scrapping around through here, maybe through National itself. Maybe I did it, I don't know, but I found one of these was, I think this one here was pushed down and it was intermittently hitting this grounding strap down here. That was one problem. The worst problem, which took me a long time to find, was these 2 gray wires here were a real pisser. So let's see, let me turn this thing off. Gray wire here. And you can see it's a real pile of crap looking wire, but that wire, and I think there's one right, yeah, these 2 gray wires were hardly soldered in, and maybe that compression fit worked for 20, 30 years, but after 60 years, those were getting oxidized. So anyway, I finally noticed that way down there and soldered those, and that got rid of some large problems. Another problem I had when feeling around on the bottom of this board was the crystal, this little capacitor, whoa, this little capacitor here. I was kind of tapping that and I could hear something tapping on clink, 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 and the signal would go off. And so this wire here, this tab was pushed all the way to hitting the frame every so often. So that was barely touching the frame, and that was a problem. So I corrected that. So there's a bunch of mechanical maladies in this thing that will just get you. I cleaned the crystal out real well, make sure it was seated well. Anyway, it's finally working again. I think in my desperation, I was throwing in silicon transistors here, trying to get the output a little higher. This output of this thing really matters. It's got to be nice and high for it to lock right and for it to figure out sync down here. It needs some good output. So I think this thing's finally up to the task. I should probably put a germanium back in there to get more output. I bet the silicon doesn't match right. But anyway, turn this turkey on now. And so yeah, and I spent a lot of time putting in voltage regulators so this thing wouldn't go too high. I think those kind of might have goofed up things too a bit, but we'll see about that. Anyway, so there's the output. Oh, that's cool looking, isn't it? There's the output, and if I lower the voltage down on the power supply, it doesn't change much. And I'm happy about that. So there the supply is down to, that's probably 12 volts. So they're pretty strict on this radio, the internal power supply, putting out 12 volts, I think. They're kind of sticklers on that. And everything goes off that 12 volt signal. So, you know, stuff like 13.8 volts from alternators in cars. This radio, I don't think ever would have worked well in a car with all the different voltages changing around. You can run this thing on a battery or something, but I think in a car it would have been too much vibration for one, for the synthesizer. It wouldn't have liked that. Yeah, you couldn't use this thing mobile. It just wouldn't have worked at all. It's got to be a stationary radio. Anyway, let's look at the voltage going into the radio right now, if I can find the wiring. Man, oh man, okay. I'm not real organized, am I? All right, here's a lead finally, untangled. Plug that into here, and let's see what our voltage is going into this thing from the power supply. I've never used the real power supply that this thing runs on. Why is my autofocus locked? There, now it's not. Okay, so what do we got here? There's the meter. Okay, 12.55 volts going in, which isn't unreasonable. And so this is a voltage control on my power supply. So at 12.55, if I lower it down to 12 roughly, the amplitude goes down a little bit. If I crank it up now to about 15 volts, doesn't change a lot, and that's good. I really wanted solid regulation on this thing. And there's, I cranked it down a good bit. There's, wow, there's like 9 volts or 8 volts or something. What do we got here? There's 9 volts. So I'm happy now that this thing has been stabilized as far as the voltage and the output from the harmonic generator. So there's 9 volts. Let's take it up to 15. 9, let's see. It's about 15 or 16. So you can see the radio lights are going up and down with the voltage increase. Anyway, so I'm getting consistent output. It's not really freaking out anymore, so I can probably put the cover back on this to keep it from being damaged and be done with it. So yeah, I'm pretty happy with that. It's not really bugging out anymore. Yeah, my significant other was saying it flatlines. It's not flatlining now. All right, and do I have a germanium to put in there? I think this one was bad. I don't think I have any more. I guess the silicon's gotta work. This thing supposedly was conducting, and they cut it off and make that magnetic field displace, and it's not hot, but at any rate. So How much current now is this thing drawing with the regulators? Not a whole lot. So I think by taking the 7.5 volt Xenier out, it's not going to eat so much current now. Anyway, this thing never did eat much current. So, all right, where does that leave us as far as locking the synthesizer? So we now have a stable harmonic, and we're on a 50 millivolt scale, which is pretty damn low. I would like a few volts out of this thing if I could get it. Does that look reasonable? Yeah, that's how it looks usually. That's kind of right. So there's 0.1 volt. So 0.1 volt. I can't even sync on something below that. Okay, so it's about 0.2 volts. It's not much. So you got about 0.2 volts there. And let's look at the HF oscillator coming in. So this coax from that switch goes over here to the comparator module, which has the IF amplifiers. And so let's look at the voltage of the HF oscillator and of this synthetic harmonic generator of 52 harmonics. So that comes in right there in this little coax here. That is where that comes in. It's like the third post over. And we should see the same signals we had before. And yeah, it looks about the same. Looks about the same exactly. So we got about 0.2 volts coming in there. And then this first coax is the HF oscillator. And that thing, that's about the same. So we have two voltages about 0.2 volts. So that's reasonable, I suppose. At least they're level. We'll come off the mixer here and take a look. And now we need to have a tuned synthesizer on some harmonic. So we're not seeing anything here. Let's diddle with this and see if we can catch a harmonic here. Okay. Nothing. I can't get a thing. So that's not a good sign. And this thing can be twitchy with the band switch. And this has to be on the right setting. So let's move it to number 4, which it was on 4. Okay, so I would expect to get a signal here. Okay, I had an offset, so let's go to AC. And let's look for something. We should get yeah, there it goes. So yeah, it's sort of working. So you should get some 4.75 IF through here, and when you tweak the synthesizer to hit the coincidence of those signals, you'll see that signal improving. So now, off the mixer, we'll go to the second IF can, or the first IF can here, which should provide some amplification, and indeed it does. So, you can see now that's extremely amplified. Well, not extremely, but what do we got here? 0.1 volts. We're about 0.4 volts, I guess, there. So here's the last amplifier. And if I attach here, that should be a nice big signal there. I think it's supposed to be like 4 volts or something, but I'm sure it's not 4 volts. What do we got there? Oh, look at that. 0.5, 1, that's 2 volts. It's not 4 volts, but it's 2 volts. And could we get any higher anywhere? No, I don't think so. So that could be a problem with locking, in that you need this thing to be cranking out some power. I'd like to get 4 volts out of it. What if I increase the voltage here? Does it make a difference? Wax it out, so that detunes it. Look at that. So that's really bad. I don't want to see that. So when I change the voltage, wax it right out. So what is that? Okay, well, it still comes back, but I really don't want voltage changes changing my frequency. That's really bad. And well, when I give it a lot of power, around 14 volts, it's really cranking good. Okay, there's 14 volts. And it looks like it's got some weird stuff going on. Okay, there we go. So that's pretty steady looking. Now, we want to look at the coincidence of the 4.75 oscillator here and this 4.75. When those are equal, we should get voltage right here. So let's go here. And this one, you want to go to DC. And now we're on DC. And that should actually, when we lock, if we lock, that should go up to a DC voltage. Let's try to lock it. And you'll see it kind of gets wiggy and weird, and then it locks, if it'll lock. It might lock, it's trying. Anyway, that's how the lock looks when it's trying to lock, and then when it locks, it'll flip up. And I'm not running the scanner right now, so the scanning transistor is out. And let's deal with the voltage here a bit. There's less voltage, and it's not going to lock, or is it? It's not going to lock there, I don't think. So I would like to get the synthesizer part really stabilized and the HF oscillator stabilized and not have it affected by voltage a whole lot. Okay, so this is not going to lock there. And what are we on here? We're on 11. I think 10 will lock here. Let's see. Let's go to 10. I think that locked before. Yeah, there. So when it locks, it'll head to the top and you'll get a fuzzy wave. There, now it's locked. It was locked, so it's barely locking. There, now it's locked. So that's a locked synthesizer right there. And what you'll notice is if I tap this thing on the side, if I tap it anywhere, it'll unlock. Well, maybe not. Yeah, I see how I tap it, and it doesn't like that. Changes the frequency, but might have to live with that. So it is locked. I could probably put an antenna on here and listen to something. So that band works. What if I go to this band here and I change the synthesizer or the generator to the middle band right there? So put that in the middle. So you get a string to work, the band switch, and this will go automatic when you're finally done working on everything. So what about now? Scope. Yeah, it's trying to lock. It's not going to lock there, I guess. What about there? No. I know if I go to 7.5, it'll lock on 40 meters. Let's see. Oh, okay. 4.5, 4.0. I think if I go to 7.5, it'll lock. 6.5, 7.5 is 40 meters. And that used to lock. Thinking about it. There, locked. So I think that's 40 meters. Or thereabouts. And it still locks. All right, so that's my demo. I think this thing is coming along. And this damn thing is finally, yeah, when you hit it, it goes out of lock. So anyway, there it's locked again. But I think the important thing now is this harmonic generator was really unstable and undependable. So yeah, let's check its signal again and just feel good about that. Third lug over is the signal from the harmonic generator, synthetic harmonic generator. So turn the power on, crank up the gain here. Here's the telltale from that thing. Give it a few whacks. Yeah, so that's what I've never had, was stability on this thing. Wiggle it around, wiggle the board, wiggle, 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 wiggle. Look at that. No problems at all. For once, it's working. Stable. I'm going like this with it. Wiggle, 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 wiggle. It's hanging in there. So I think I can put the cover back on this thing and call it fixed. And maybe this too. If you put the cover on, you're not going to be breaking little wires in here and busting things. So maybe the cover, once it's working, put the cover on. I guess I could put in the correct transistor if I have one. That's an NPN, I think. I don't think I have. I had this NPN here, but I think it's bad. Maybe I could throw it in there and see what it does. Pull that one out. Turn the power off. I think this one's bad though, but let's try it. Let's see what happens. Try and put this guy in here. It's in. Yeah, that one I think's bad, but let's start it up. Yeah, nothing coming out of there. So that transistor is gonna go into the S pile. So I should probably put a germanium NPN back in there. I have to buy one or something. It might have a little more gain than a silicon, I don't know. Anyway, there's silicon back in there. Scope came off, put it back on. 1, 2, 3, here we go. Powered up. There's the wave. I think this is as good as we're gonna get tonight. All right, that was my demo. Yeah, I did harm this radio by putting in too much voltage into it, and I blew the bulbs out. I probably blew out, I don't know, a couple of transistors here and there. Anyway, let's go over some more work I did on it beforehand tonight. So I did kind of go nuts on the bottom of this thing and went regulator happy. Let's take a look at that real quick. I'm trying to stabilize this thing, so I want to tip it over and take off these wires and tip it over. Let's try that. Tip it over against the computer. And there it is. Okay, so I did put in all these regulators today, which I'm not sure it helped. I'm trying to stabilize this thing, so they had a Xenier in here for 5 volts. I took out that Xenier and I run the power was powering that Xenier into this 5 volt regulator, which is an active regulator, and I bring back that 5 volts and I feed it through, I think, this wire. So that's how that works. This regulator here is an 8 volt regulator, and so I take this Xenier for 7.5 volts was being fed by 12 volts. I'm now feeding that resistor, and I think this is a 42 ohmer. I'm feeding that with 8 volts instead of 12 volts. So it gives this thing an easier job, and hopefully it'll regulate better. So that's my 7.5 volt regulation. I think I only got 7.1 volts in here though. And the 5 volts is taken care of here. Now, I kind of went crazy and thought, well, why don't we try and regulate the whole 12 volts? So this is a 12 volt active regulator. And so I take the 12 volt signal that was coming off one of these blue wires. So I think this wire here On the switch is the 12-volt signal, 12-volt current that was feeding into these posts here. There were 4 blue wires. One of them was this wire, and the rest were just going off. So I figured, let's try and regulate everything with 12 volts, and I put all the wires into a bunch down here, so you'll see all the 3 blue wires that were there are now ganged into 1 wire, and that's going here, and that is being fed. These 2 terminals are, this terminal and this terminal are pretty much soldered together, so as National did it. So this wire here is coming off of the 12-volt regulator output right there. So again, I'm feeding 12 volts into a 12-volt regulator, which was feeding into here through a blue wire, and I could trace that out. Let's see, there's a blue wire in here somewhere. Just trust me, it's in here. Let's see, where is it? There it is. So there's the blue wire that had a 12-volt source right there. That's the source wire that pretty much was coming from the switch right here. And so that goes into 12-volt regulator and goes out and feeds this stuff here. So now we have regulated 12 volts. I guess the good thing about that is if this thing gets a high voltage spike again, hopefully it won't burn stuff out. So that's was the thinking there. Plus, I was trying to stabilize the VCO. So what's interesting is I really should figure out what this voltage control oscillator here runs at and put in another regulator over here for it so that it won't over voltage maybe, and put a big capacitor here to regulate the power a little more. So that's the thinking there. I also removed all the really stiff wires that were in here that went to the tuning capacitor for the HF oscillator. So those have all gone to little tiny wires here, which maybe not are the best for HF frequencies because of skin effect, but I didn't want any mechanical conduction from the band switch. Oh yeah, and these wires went right to the band switch. This one here, where is that wire? One of these, yeah, this one here went right to the band switch. I'm like, sheesh, they had a big metallic heavy-duty wire from the band switch to that capacitor, and I just thought, that's nice, but a lot of mechanical coupling between the band switch and that capacitor. And I suppose when you're changing bands, who cares about coupling? But that capacitor is so microphonic, I just wanted to have it physically disconnected mechanically from a stiff wire. So I'm not sure that helped or hurt. It seems like nothing is working any worse for that change. So that's it. And here's the band switch I put in because I destroyed the old band switch that was in there. In fact, here it is, the old relic of a band switch. It was pretty bad as it was, and I destroyed it by changing out the fiberglass rod to a aluminum rod. This is an old Drake TR6 rod that somebody had in stock, probably from when Drake folded, so I bought that and sawed it up, put it in. The problem was when the fiberglass rod was in here, there was a lot of wear at the fiberglass, and these wafers seemed to be out of sync a good bit. So that was the first thing to do. I still think there's some work to be done on these wafers to clean them up because they don't seem to be real steady, but yeah, I've been determined to fix this radio, that's for sure. All right, so that's where I'm at. I want to do a test on the radio now and see if it will work on receiving anything tonight, but this is the nitty-gritty gory details on putting in the regulators for 12 volts and 8 volts for the 7.5 Xenier and 5 volts that powers, well, 5 volts does power the Spectrum generator. So yeah, I don't know if I can make this radio any better as far as stable, but I'm trying to get it working, period. All right. Thanks for watching. Again, this is the National HRO 500, a radio which cost $1,500 in 1965. How much would that be in 2024 money? And is this radio worth $1,500 in 1965. I highly doubt it because I don't find it's very stable. But it seems accurate once it's working. I guess the opinion is for history and people on Electric Radio Magazine. Okay, take care. Have a nice day.